Why can't a rechargeable cell be discharged all the way to 0 volt, and why we can't charge it beyond the charge cutoff voltage? Hello, my name is Vivek. Welcome back to the channel. Today in this video we are going to discuss about this important question. So let's get started. So you must have to understand how does a cell operate. While you are charging a cell, let's say if I talk about an NMC cell, the charge cutoff is 4.2 volt, discharge cutoff is 3 volt or 2.8 or 2.5 volt depending on various manufacturers. So you should not discharge below this value and you should not charge beyond 4.2 volt, right? So if you are charging or discharging, what is happening within the cell? The ions are moving from one side to the other side. That is, while charging, the ions move from cathode to anode. While discharging, these same ions move from anode to cathode. So what is important for the cells to be efficient, that all these ions, most of them, maximum amount of these ions move from one side to the other side without facing much resistance, without facing much problem within the cell itself. So who ensures that these ions move from one side to the other side, and therefore the cycles of the cell remain as high as possible? So this is facilitated by the electrolyte. Electrolyte is the material that carries these ions from one side to the other. Now what is important for this electrolyte? What is the one of the most important property of this electrolyte? The electrolyte should be chemically and electrically neutral, because ions by nature would like to associate in any chemical reaction and therefore form a stable compound. So within the cell, the reduction oxidation chemical reaction is happening. Oxidation happens on the side which donates the electron, and reduction happens on the side which accepts the electron, right? So in this redox reaction, it is very much important that the electrolyte doesn't participate, and for that to happen, it is important that certain conditions are matched. One condition is the temperature. If you are operating the cell within a certain temperature range, it is okay. But if you exceed a certain temperature, whether you go beyond a certain temperature or go below another temperature which is mentioned in the data sheet, what you are doing, you are destroying the electrolyte itself, which means the electrolyte will dissociate itself within the cell and it will trap these ions. Instead of transporting them from one side to the others, it will trap these ions and start forming compounds, unwanted compounds within the cell, which will lead to generation of vapor within the cell, and the cell may also catch fire. Over the time, if you are doing this every now and then, you will start seeing the formation of more and more solid electrolyte interface. In my earlier video where I discussed about the harmful effect of fast charging the cell, I mentioned about the SEI, so you can check that out, solid electrolyte interface. So the bottom line is that the cell must be operated within a certain temperature range and also within a certain voltage range, so that the electrolyte remains chemically and electrically neutral and it doesn't trap these ions itself and start forming compound within the cell. That's why you see that these two voltage ranges exist, and that's why you cannot discharge the cell all the way to 0 volt. This is true not only for lithium ion, it's true for lead acid, it's true for lithium ferrophosphate or any kind of cell you talk about. So I hope in this video I made it very clear that why these two voltages exist, how these two voltages are decided. It's not that you cannot charge the NMC cell, for example, beyond 4.2 volt. Technically speaking, you can charge it to 4.5 volt and you can discharge it to 0 volt. But in both of these scenarios, you will be breaching the electrochemical stability window, which is the range within which the electrolyte within the cell remains stable. So it is for the electrochemical stability window that both these ranges or both these values exist, for temperature, for voltage, or for whatever you talk about within the cell. I hope this video gave you much clarity about the operation of these cells. If you found this video to be helpful, share with your friends. Let me know in the comment section about your suggestions, query, questions, whatever. I'm happy to help you. And consider subscribing to the channel if you haven't already for more such interesting contents. Hit the bell icon notification button so that you receive the notification of every single video that I'm making. Thank you very much and have a great day.